There are three objectives in this experiment. Number 1, to study about compass and bar magnet. Number 2, to study the number of lobes in an electromagnet and field strength of electromagnet. Number 3, to measure the voltage and field strength in an electromagnet. Theoretical background. Permanent magnets are made from ferromagnetic materials in which the electrons circulating around the nuclei behave much like current-carrying wire loops. The field from a single atom is extremely small, but when a large number are put together, the magnetic field can get quite large. To make a ferromagnetic material into a permanent magnet, the individual atoms or current lobes must be preferentially aligned in one direction. This magnetizing process is usually done by putting the material in strong magnetic field. The field lines continue inside the magnet but appear to merge from one end and re-enter at the other end. The end from which they originate is traditionally called the north end of the magnet, and the other is called the south end. For a solenoid or coil, the end from which the field lines appear to originate is called the north end, and the end toward which they point is called the south end. This north-south naming convention arises from the behavior of such magnets in the Earth's magnetic field. In playing with magnets, you have probably noticed that when identical magnets are placed near each other, they may be attracted or repelled depending on their relative orientation. The north end of one magnet will attract the south end of the other. Similarly, two north ends or south ends placed close together will repel each other. A compass needle is simply a small permanent magnet mounted so that it is free to turn. When a magnet such as a compass needle is placed in a field of constant strength, there is no net force. Each end experiences an equal but opposite force that tends to turn the magnet so that the north point in the direction of the field. In the earth field, the north end of the magnet points towards the earth north pole. Apparatus and material: compass and bar magnet.
Procedure. Link was clicked in the description. The compass was moved around the bar magnet. The flip polarity was clicked in the right menu. The reset all icon in the right menu was clicked. And then the box Show field meter in the right menu was checked and a blue box appeared. This measures the magnetic field around the magnet. The magnetic field is measured in gauss. The field meter was moved around the magnet. The meter was moved so that it's about 1 inch away from the north end of the magnet. The meter was now moved the same distance away from the south end of the magnet. At the top left of the simulation window, the electromagnet tag was clicked. A battery was connected to a wire with loops that has current running through it. The compass was moved around the electromagnet. Show field meter in the right menu was clicked. Show field meter in the right menu was clicked. The meter was moved around the electromagnet. The meter was placed about 1 inch on the screen from the left side of the electromagnet. In the right menu, the number of loops in the electromagnet were adjusted. For each number of loops, the field strength was written down in the table below. The number of loops for the electromagnet was set back to 4 and the field meter was 1 inch from the left side of the coils. The voltage in the electromagnet was adjusted on a sliding bar of the battery. The voltage on the battery was adjusted and the field strength at each voltage was written down in the table below.
So this is data that we get from the experiment. Based on the data above, the amount of field strength is increased when the number of loop is increased. Then this is a graph from the data that we get. Now for second table, based on the data above, the relationship between voltage and field strength of electromagnet is when the voltage increase, the amount of field strength also increase.
Discussion. Which pole of the magnet does the red compass needle point towards? The red compass needle points towards the south pole. Now, which pole of the magnet does the red needle point towards? Does it still point towards the same pole? Yes, this means that the red part of the needle is a south pole. Does the field increase or decrease as you move the meter closer to the magnet? The field increases when the meter closer to the magnet because the current flow is stronger near the magnet. What is the magnitude of field strength in Gauss? The magnitude of field strength of north end of the magnet in Gauss is 1.47 G. Is the amount of magnetic field the same for both north and south ends of a magnet? The amount of magnetic field is same for both north and south ends of magnet. Is the left side of the electromagnet the north end or the south end? How do you know? The south pole is the left side of the electromagnet. That's because the north pole is the red compass needle so that it can attract towards the south pole that is the opposite pole. Does the field strength increase or decrease as you move the meter closer to the electromagnet? If the meter closer to the electromagnet, the field strength increases. Conclusion. From this experiment, 1. We are able to determine the polarity of magnet. Second, we are able to determine the magnitude of magnetic field strength. Third, we are able to study relationship between loops and field strength. And fourth, we are able to study relationship between voltage and field strength.